All right, so yesterday, okay, we talked about acceleration, kind of reviewed what it is. We went over the first 2 of 5 acceleration formulas. We reviewed this one from last year, okay? We introduced this one and worked on it a little bit yesterday. So we still have 3 more to get through today, okay? So what we're going to do is look at what our givens are for this problem and then see how we do with it. All right, so in this one, we have a golf ball that is initially traveling at 25 meters per second. So they just told me VI. Okay, it hits a sand trap and slows down with an acceleration of negative 20 meters per second squared. All right, find its displacement after 2 seconds. Okay, so this is what we know. We have time, we have acceleration, we have initial velocity, and we are looking for D. So which one of our fancy new formulas should we be using for this one? Darren, which one? Give you hints. One of the first 2. What? Nope, no, it's not one of the ones we did yesterday. Sorry, one of the first 2 in the list in your notes. Okay, I'll write it down. It's this one. VI times T plus 1/2 AT squared, right? I'm looking for D. I have initial velocity. I have time. I have acceleration. All right, so I've got all the things that are part of this. Remember, this is the one I told you you wouldn't have to solve for T if VI was not 0. Okay. So in this one, I don't have to manipulate. It's set up for D already, which is nice. Okay, so I'm going to solve here for D just by plugging in my numbers. They told me the initial velocity is 25 meters per second. Okay, this happens for 2 seconds. Then 1/2 times the acceleration, which was negative 20, times the time squared. So times 2 squared. Okay, everybody all right with what I've done there? All right, so we have 25 times 2, which I can't believe I actually typed in, but I did. Okay, times 0.5 times negative 20. Important to have that negative in there or this won't come out right. It'll say that by slowing down, it went way faster. Okay, be on the lookout for that. I see people make that mistake all the time on tests. Okay, they're using this formula, acceleration's negative, they forget to make it negative, and even though the question specifically says it's slowed down, they write down an answer that says it's sped up. Okay, always make sure your answer makes sense within the context of the question. All right, so its displacement is going to be an even 10 meters. Right, it'll travel 10 meters forwards, I guess. They didn't really say forwards, but it'll be like positive because they gave us a negative in here, I guess. So D will equal positive 10 meters. All right, everybody okay with that one? Okay, so manipulation of this formula, some other things we might have to solve for. Okay, let's say I need to solve for VI. What should I move first if I want to solve for VI? Pardon me? The stuff that's not attached to it. So like this entire term, can I move it all at once? By subtracting it over to the other side. All right, so I'm going to have D minus 1/2 AT squared equals VI times T. All right, I want VI by itself. What do I do with T? Divide by it. Okay, here's a mistake people make. They go, oh, T on the bottom, T squared on the top. Those cancel. No, they don't. Okay, those do not cancel in this case because there is another operation on top, the subtraction operation. I can't cancel it. If everything on the top was being multiplied, then yes. Okay, but because there's a subtraction operation there, that T does not cancel off. All right, so that's how I would solve for VI. All right, I want to solve for acceleration. Should I start off similar to what I did before? Okay, subtracting off VI times T. Okay, so D minus VI times T equals 1/2 AT squared. All right, I want A by itself. What do I do with the half and the T squared? Divide them over to the other side. Okay, and I'm left with A. Everyone good with that? All right. I have a question where VI is 0. And I want to solve for T. If VI is 0, I can just do this, because 0 plus anything is itself. Everyone okay with that? All right, now how do I get T by itself? Right, divide by half of A, and then what? Square root. All right, those are the manipulations of that formula. Now, I sat down this morning, because I have to sit down and think about how to solve this if. Okay, I told you wouldn't have to solve for T, okay, if VI was not 0, but just in case you're super math strong and you want to know how that works, I wrote it down. I had to sit down and work it out because I don't do that very often. Okay, so what we would have is that essentially this is like, it's like quadratic, right? So it's AX squared plus BX plus C equals 0. Okay, is that ringing a bell? If you're taking Math 20, you've probably seen that formula before. Okay, essentially what we're doing is we're making A, okay, our acceleration, we're making B our speed, and we're making C our time, essentially. Okay, so what we're going to do is we're going to manipulate this. Okay, sorry, we're going to make X our time. Sorry, not X is the thing in two places. All right. Sorry, C is our displacement, sorry. So C will be our displacement. So what we end up with, if we're solving for X here, is we got X equals negative B plus the square root of B squared minus 4AC, because I'm sending that exponent through, okay, over A. Okay, sorry, over 2A, sorry. Then I'm gonna, sorry, I got ahead of myself, looked at the next step. Then I'm going to further modify this, okay, with the 4 and the 2. Okay, so I will have X equals negative B plus the square root of B squared minus 2AC over A. All right, now what I do is I substitute in the actual letters from the formula. Okay, so we said here before that X was going to be time. Okay, B was going to be our speed. Sorry, so negative VI plus the square root of VI squared plus 2AD over A. Aren't you glad you're not going to have to do that? That took me like 20 minutes this morning. I'm kind of ashamed to admit that that took me like 20 minutes, but it took me like 20 minutes because I never do that. Okay, and yeah, well, grade 11 was more years ago than I care to admit. Many, many more. Okay. You won't have to do that. Forget it all, unless you were really, really interested in it. Forget it all. Okay. I want you guys to try these two here. Okay. They have to do with that formula we just used. All right. They're just going to ask you, the first one's wanting you to calculate displacement, but the other one is, also asking for displacement. But here's the thing, with both of those, sorry, not with both of those, with the second one, you've got this problem we ran into yesterday. You got kilometers per hour, you got minutes, you got meters per second squared. All your units have to match. Okay, so you have to do that 3.6 conversion here with the kilometers per hour. You're gonna have to convert the minutes to seconds, which isn't hard because it's only 1 minute. Okay, just remember that all your units have to match. All right, I'll give you a few minutes on that one, then we'll walk through those two. Okay, so for question number 1, okay, we're told the skier is moving down a uniform slope at 3.0 meters per second. So that would be our initial speed, okay, our initial velocity in this case, downhill, right? If the acceleration down the hill is 4 meters per second squared, okay, and we'll just write downhill, okay, we'll write same here, downhill, okay. We want to find the displacement after 5 seconds. Okay, so do I need to manipulate this formula at all, or can I just plug in? right? I'm looking for D, so I can just plug in, no manipulation required here. All right, so we're going to have our 3.0 times 5.0 plus 1/2 times 4.0 times 5 squared. Okay, that's what we're looking at there. We don't have to worry about anything being negative because everything was down the hill. He's not changing direction at any point. Okay, so we don't have to worry about that. All right, so we got 15 times, or sorry, not times, plus 0.5 times 4 times 25. All right, so 65 meters downhill. Okay, and again, this is the mistake that this book always makes. They associate down and downhill as the same thing. They are not. Okay, this is downhill. This is down. Okay, down is straight down. Right? You can't fall straight down a hill. Okay, you'd have to fall through it towards the center of the earth. Okay, you could do that if you dug a hole, but then you're not falling down the hill. You're falling down the hole. Okay. Yeah. All right. How many people are done number 2? Okay, do we need to go over that, or do we just need a minute or two still? Minute or two? Okay. All right, so number 2 is another one of those questions where it's kind of a reading comprehension thing. Okay, we have to understand that when we apply the brakes, we're slowing down, and that's a negative acceleration. Okay, it doesn't outright say that the 0.8 meters per second squared is negative, but it implies that, telling you that you produce that by applying the brakes. Okay, so what we have here first is we have VI. It's 100 kilometers per hour. If we divide that by 3.6, we're going to get 27.7 repeating meters per second, and I'm going to make that positive because it was forwards. Then we apply the brakes, producing an acceleration of negative 0.8 meters per second squared. Okay, and we're doing that for a time of 60 seconds because we got to convert it to seconds, and looking for the overall displacement. So again, we don't have to manipulate the formula. Okay, VI times T plus 1/2 AT squared. We're just going to plug in our numbers and solve. Okay, so we'll have our 27.7 repeating times 60 seconds plus 1/2 times negative 0.8 times 60 squared. All right, so 100 divided by 3.6. Okay, and the reason I'm doing that is I want all those decimals. Remember, we want to keep all of those all the way through. Okay, so times 60 plus 0.5 times negative 0.8 times 60 squared. All right, so we only have 2 significant figures here. Okay, so we are looking at 2.3 times 10 to the 2 meters forwards. Okay, which is what they got as well. Okay, and that's something else to check here, guys. Obviously, this number only has 2 significant figures. This number also only has 2 significant figures. Okay, leading zeros, which are essentially place-holding zeros, are not measured values. There isn't anything to measure at this position, and you cannot measure nothing. Okay, this 0, on the other hand, wouldn't have been written unless we were sure it was actually a 0 and not a 1 or a 2 or whatever. Okay, so trailing zeros are always significant. Leading zeros are not. Okay, just in terms of significant digits from yesterday. All right, any other questions on those? Okay, so we're going to go over this one here. I'll just give you a minute to write it down, and then we'll look at it. Okay, so next formula that we haven't gone over yet. So we have a speedboat that slows down at a rate of 5 meters per second squared. So they gave me the acceleration, and the acceleration is negative. All right. Okay, and comes to a stop. So VF is 0 meters per second. Okay, if the process took 15 seconds, find the displacement of the boat. All right, so this is the counterpart formula to the one we were just using, the VI times T plus 1/2 AT squared. Remember, that's the one that finds the area underneath the line, both the box and the triangle. Okay, this is the one that finds the whole rectangle and then subtracts the triangle from it. Okay, so we're looking at D equals VF times T, okay, minus 1/2 AT squared. So this is the big, okay, remember on our velocity versus time graph, VF times T finds this whole rectangle and then subtracts this triangle off. Okay, that's what this is here, okay, to give us, again, that displacement, okay, in there. All right, so in this one, I don't have to manipulate it all, okay? It's just going to be plugging in the numbers. So I'm going to plug in the numbers, not the letters. Okay, so that'll be 0 times 5 squared, or sorry, 0 times 15, sorry, which is 0, obviously, minus, okay, 1/2 times negative 5 times 15 squared. Now, why did I not just get rid of this? Like, when this was VI times T, I just crossed that off. Why did I not cross it off here? The difference is adding 0 to something makes no difference. But if I'm subtracting something from 0, I need to keep it there. Otherwise, I might not end up with the right signage on my answer, okay, or the right vector on my answer. All right, so what I'll end up with here is 0 minus this number, which is actually also going to be negative, right? That's important because I'm moving forwards this whole time. My displacement will be forwards. I'm slowing down, not going backwards. All right, everyone okay with that? Okay, so this makes sure that we get the right signage on our answer. So we will have 0 minus 0.5 times negative 5 times 15 squared. All right, so we're getting, and I think we only have 2 significant figures here, is that right? Yes. Okay, so we're going to get 5.6 times 10 to the 2 meters, positive 5.6 times 10 to the 2 meters. They don't actually outright say forward in the question, so we'll just leave it as positive here in our answer. Okay. Oh, okay, sorry, scientific notation. So 562.5 was my answer, okay? I know I have to cut off my answer and only include these 2 numbers. That means I have to move the decimal 1, 2 places. And every one of our places is a factor of 10. So 10 to the factor of 2, yeah? Okay. All right. You guys try those 2. Okay, same formula. And you can do both of those. This one does ask you to solve for time, but VF is 0 in it. Okay, so you guys can do that one. All right, so for number 1 here, okay, we have one of those arresting cables on an aircraft carrier. If you've ever seen like a plane land on an aircraft carrier, there's a cable that goes across the deck. They have a hook, it catches it, and it jerks them to a stop, okay, because an aircraft carrier is not long enough to actually land a plane on and have it slow down on its own, okay. So what we have here is a displacement of 150 meters, okay, that's a positive number because it's forwards, okay, an acceleration of negative 15 meters per second squared. That's pretty sharp. Okay, and we are trying to find the time it takes the plane to stop, okay, and because it says it stops, we know VF is 0 meters per second. All right, so we've got the D equals VF times T minus 1/2 AT squared. Now I know that VF is 0, so what I'm going to do is take this out, but I'm going to leave the negative there. Okay, that way I can move the negative over, and again, I'll preserve the direction traveled, okay, during this thing. Okay, so I'm trying to find the time, so I'm going to get time by itself, I'm going to divide both sides by negative 1/2 of A. Okay, that's going to give me T squared. Then I'm going to take the square root of that to get T. All right, so when I plug in my numbers, and again, this is where keeping that negative is going to be important. If I don't bring this negative over, my calculator won't do this. Why not? It won't take the square root of a negative number. It is impossible to have a number that is negative that was the result of squaring something. Okay, so we will have here 150 meters positive on the top. Okay, and then on the bottom we'll have negative 1/2 times negative 15. That'll help cancel off the negatives. Okay, and I will end up with a positive number for time. So 150. Okay, so we'll have the square root of 150 divided by negative 0.5, okay, times negative 15, and I should have put that in brackets. All right, so this is going to be 4.5 seconds because I think we only have 2 significant figures here. All right, so that's going to take 4.5 seconds, which is what they've got for an answer there as well. All right, everybody okay with that one? Questions on it? All right. I'll give you a couple more minutes to get the second one done. Okay, it's got that kilometers per hour thing in it again, so don't forget about that. Okay, we got to have all our units match. So there's actually a couple of ways to manipulate this one, okay, to solve for acceleration. The way I'll do it is the way that makes most sense to me, but you can do it another way as long as you remember that you might accidentally get a negative time, or sorry, a negative acceleration. Obviously, you can't speed up if your acceleration is negative, okay? So you just have to watch out for that. So here's what we have in this one. We know that the time for this acceleration is 6.2 seconds. We know that the final velocity is 160 kilometers per hour, which we need in meters per second. Okay, so that's going to be 44.4 repeating. Meters per second, that's a positive value. Okay, it traveled that's north. Sorry, they gave us actual compass directions in this one. Okay, it traveled 220 meters north, so that's its displacement. We're looking for the acceleration. So we're going to be using this formula, displacement equals VF times T minus 1/2 AT squared. All right, so this is where you can manipulate it one of two ways. Some people will move the VFT over by subtracting it, and that's fine. But if you do that, you have to realize that you're leaving a negative over here when you do. Okay, for me, I don't like doing that. I don't like solving for things when they're negative, so I add the 1/2 AT squared over to this side. Okay, so I end up with this D plus 1/2 AT squared equals VF times T. Then I subtract the D over. Right? So now I have 1/2 AT squared equals VFT, which is a displacement, minus this displacement. Okay, I'm trying to find A. Everything's now multiplied together. So I just divide both sides by 1/2 of T squared, and that leaves me with positive A. Okay, so now I can plug in my numbers. So that'll be 44.4 times 6.2 minus 220, right? That was our displacement, 220. Yeah. Okay, divided by 1/2 times 6.2 squared. Okay, that'll leave me with A. All right, so I get 2.9 meters per second squared, and it ends up positive because I've made sure I've maintained all of my positives and negatives throughout the manipulation. Okay. Okay. If you accidentally lost track of the negatives and you got negative 2.9 meters per second squared, okay, you'd hopefully just look at that number and then look at the question and go, oh, I must have screwed up the signs. This can't be negative because it says it's speeding up, and you just, all right, I'll just pretend it's not negative anymore. Okay, and sorry, this should be north because they gave me compass direction of north in the question. Okay, everyone all right with that one? Okay, we only have one more formula to get through. We might actually get through it. We'll see. Okay, all right. Copy this one down. Okay, we got a bullet accelerating through the barrel of a gun, which is 0.750 meters long. Okay, with a magnitude of 5.35 times 10 to the 5 meters per second squared. That is an incredibly large acceleration, but well, that's how bullets work. They're propelled by an explosion. Okay, what speed does the bullet exit the barrel? So we'll be looking at that here. I'll give you a sec to get it copied down here. I'll make it a little bigger. All right, so on this question here, we have the displacement of the bullet, which is the length of the barrel, right? When the gunpowder explodes, there's just almost an airtight seal except for the rifling part, okay, that allows the expanding gases to push on the bullet for the entire length of the barrel of the gun. So it's being accelerated over a distance of 0.750 meters, okay? And we know that the acceleration is 5.35 times 10 to the 5 meters per second squared. They don't outright say this, but what's the initial velocity of the bullet? 0. Yeah, okay, we have to assume that. They don't outright say it, but given the context of the question, we have to assume that that's the case. Okay, the bullet wasn't already moving when the hammer struck it. Okay, all right, we are looking for the final velocity, or in this case, actually the final speed of the bullet as it exits the barrel of the gun. All right, so I'm looking for VF. I've got VF, VI, A, and D. So the last formula we haven't gone over yet is this one. VF squared equals VI squared plus 2AD. All right, we are looking for VF, so we still have to manipulate. What do we have to do? We have to square root it. All right, so VF, which is what we're looking for, will be the square root of VI squared plus 2AD. Okay, and a lot of people will make this mistake. They'll go, oh, I got a square root. I don't have to square this anymore. Yes, you do. Okay, you do still have to square that, unless you're going to go VI plus the root of 2AD. Okay, which is really, don't bother. Just square that, then square root everything after. Okay, so what we'll have is VF equals the square root of 0 squared plus 2 times 5.35 times 10 to the 5 times 0.750. Okay, so is this bullet going to be going pretty fast? Yeah, with that kind of acceleration, definitely. Okay, so we will have the square root of 2 times, in brackets, 5.35 to the power of 5, okay, times 0.750. All right, so it's going to be traveling at just under 900 meters per second, which is around 3 times the speed of sound. Frightening fact, you will never hear the bullet. It's going faster than the shot that produced it, which means it would hit you before you heard the shot. Scary, yeah, okay. So we got, there, you can just rock yourself to sleep tonight with that. We got 800 and we got 3 significant figures here. So that'll be 895 meters per second is the speed of the bullet when it exits the barrel of the gun. Okay. Yeah, so they go really fast. Okay. In fact, the longest kill shot, the record for longest kill shot is actually held by a Canadian sniper. Okay, in Afghanistan, he made a successful kill at nearly 4 kilometers, and it's like 3.7 something. It was long. It shattered the record by almost a factor of 2. Okay, and they've shown like footage of other shots that this guy has made, and when he misses, the people look down because they don't hear a shot. They hear the bullet hitting the ground, and they see the puff of dust. Then they hear the crack of the shot if they're close enough. From 4 kilometers away, you might not even hear it, okay, at all. The sound might not travel that far, right? But that's an incredibly long shot, okay? You have to take into a lot of things into account to make a shot like that. Crosswinds, how much the bullet will fall as it flies, because every second it falls like 4.5 meters. Okay, so it's always falling. That has to be corrected for. So he had to aim way above his target, okay, and account for the fact that the bullet would fall. The bullet would be pushed by the wind. All of that stuff over a 4-kilometer shot. Okay, yeah, it's crazy. It's scary actually that somebody can hit a shot like that because you're never safe then. Hey guys, sleep tight tonight. Okay? Yeah. Yes, they are. And what do? They invent ways to kill people. Scary. Yeah. Okay? I mean, what were the best scientists doing in the 40s? All the best scientists were figuring out how to build a bomb. Okay? Yeah. That's how we think. It's scary. Okay. All right. I want you guys to try these 2. They have to do with that formula, and then we're done with just, hey, here's a formula. Try some. Okay. We'll do something else after that. Okay. We run out of time. Okay, so for question number 1, we have a jetliner that lands on a runway at 70 meters per second. So they gave us VI. Okay, it reverses its engines to provide braking, comes to a halt 29 seconds later. What's its acceleration? Okay, can I use my first formula for this one? I can use VF minus VI over T for this, right? Okay, and I should, because that's the easiest one to use for this. All right, so A equals VF minus VI over T. That'll get me the acceleration. So we'll have 0 minus 70 over 29. And that'll give me a negative acceleration, which is fine. It is negative. It's slowing down. So 70 divided by 29. All right, now that I have that, the 2.4 meters per second squared, and it's negative. Now I can solve for part B using the formula we just looked at, this one. VF squared equals VI squared plus 2AD, because I have everything now but D. I just calculated A, and I can now use it in this formula. All right, so manipulating for A, I would subtract VI squared. So I'll have VF squared minus VI squared. We'll talk about the rest of that on Monday. Okay, have a good weekend, guys, but not too good.